We can solve this problem by two methods. The first one is standard method. So first of all, we can find horizontal displacement, and then you can find this height, and d, with the help of Pythagoras theorem, x squared plus h squared will be equal to d squared. So you can solve in this way. To solve in this way, of course, our x and y axis will be in standard way. So this will be x and this will be y. This is origin. Second way, very similar to this one, but we will choose our y and x axis in different way. So the surface of this inclined plane will be our x axis. So like this. This will be our x axis. And the y axis, of course, perpendicular to the x axis. So it will be directed in this direction, and this will be origin. So basically, after t time, or when this object again reaches the surface of the inclined plane, it will be traveled in x direction, d distance, which we need to find, which we need to prove, and y is basically height will be again 0. So here, for example, till maximum height is increasing. After maximum height, approximately here, height will decrease, and at the end it will become 0. So this is what we are planning to do. Now let's write some equations. Before writing equations, we need to write gravity acceleration in terms of components, because our x and y axis is rotated for phi theta basically. So here we have a, let's say, gravity which is exactly vertical, but it's not vertical according to our new axes, yes, x and y. Basically, let's say it will be better to draw it here, and this part will be 90 minus not theta phi. So the vertical component, this component will be g gravity times sine theta minus phi, which is gravity times cosine phi. This is a component of the gravity in y direction, and in x direction it will be directed downward like this. It is g times cosine 90 minus phi, which is g times sine phi. So let me draw it again so you could understand it better. I will rotate it, my x and y axis. So be careful. This is our x axis. I'm just rotating the figure basically. This is the y axis, 0. And we have a gravity downward, which is g times, I think it's a cosine. Yes, downward is cosine phi. And to the left, we have a gravity times sine phi. Sorry, phi. If you remember in previous questions, we said that there is no gravity in x direction because there is no force. But this problem is different. Here we have an acceleration in horizontal direction, so we should be careful. So this will be initial velocity, and this angle will be theta minus phi. So basically this part, we need this angle. We need this angle, which is theta minus phi. Now this is a trajectory, and it will come back to the ground, basically to the surface of the inclined plane. As you see, height again becomes 0, and in x direction, in horizontal direction, in x direction, displacement will be d. And let's write our equation number 3 for x and for y, for both directions. In x direction, after t time, displacement will be d. Velocity, initial velocity in horizontal direction is v initial times cosine theta minus phi times time minus, because gravity in x direction is opposite to the x. So this one basically. Gravity is opposite to the x direction. That's why we use negative sign here. So 1 over 2 g sine phi times time square. Now let's write the same equation for vertical direction, for y direction. Height becomes 0 after t time, initial velocity in vertical direction, in y direction, which is sine theta minus phi times time. Again minus, because gravity also in y direction opposite to the y axis. So 1 over 2 g cosine phi times time square. So till this part, till this point, physics. Further, it's just totally mess. So let's number these two equations. First one and the second one. From the second equation, I think we can get time. So if we do simple calculations, one over 2 g is, which basically 5, yes, 5 cosine phi. Yeah, let's leave it as a g because answer is in terms of g gravity. Sorry. So g over g cosine phi times square over 2. We can cancel both sides by time. So from here, time equal to v initial sine theta minus phi divided by gravity times cosine phi. Now we need to take this time and substitute into the first equation. So here and here, that's all. And after some simple calculations, I hope we will get the same result. So let's continue. Let me copy the equation number 1. So d equal to v initial times cosine theta minus phi times time, and time was equal to 2 times v initial sine theta minus phi over g cosine phi minus 1 over 2 g sine phi times time square, which is 4 vi square sine square theta minus phi divided by g square cosine square phi. So first is just simple calculations. D equal to, we can take outside of the parenthesis bracket v square from both sides, and here will be g. We can take outside g, one of the g, and the cosine phi here, and also 2. Here we have a 4, but it will be cancelled by 2. So here we have a 2. One of the g will be cancelled here. Okay, so we can take outside of the bracket 2 vi square, here g and the cosine phi, and in the bracket we have a cosine theta minus phi times sine theta minus phi. Here we have a sine phi divided by cosine phi times sine square theta minus phi. I think we can also take outside the sine theta minus phi. This part we can also take it outside. So d will be equal to 2 vi square sine just theta minus phi g cosine phi, and here we will have cosine theta minus phi minus sine phi divided by cosine phi times sine theta minus phi. Now, as you see, we can write it in this way. This part we can write in different form. So here it should be phi. So cosine phi times cosine theta minus phi minus sine phi times sine theta minus phi. So we can write the upper part, this part, in different form. Basically, this is a trigonometry, which is cosine phi plus theta minus phi. Basically, cosine alpha plus cosine beta, like. So let's continue. D equal to 2 vi square sine theta minus phi divided by g cosine phi. Cosine phi. Here we have cosine first angle phi plus second angle theta minus phi. So phi will be cancelled. So we have only cosine theta. So our final answer will be like this: 2 times vi square times cosine theta times sine theta minus phi divided by g cosine square phi. This is a final answer.